In lesson 2.3, we will be focusing on lines, writing the equations for lines, finding the slope of a line, graphing a couple of lines. So hopefully this is going to be a review of a topic, some topics that we touched on in Algebra 2. So let's get started. All right, so the first couple of problems these are your instructions. You'll be plotting the points that are given and determine the slope of the line that contains them, and then sketch the graph. So you got two ways of coming up with slope. You could go ahead and plot these points, 2, 3, 4, 0. And then you could just use the old expression rise over run, up 3, which would be positive, left 2, which would be negative. And you could come up with the slope that way. You also, from time to time, sometimes you don't have a graph to look at, and you're not able to plot the points literally. You can always use the slope formula. That's going to come in handy in some of the problems in this lesson. So let's just go ahead and review that. So this is the slope formula, y2 minus y1 over x2 minus x1, and we would get the same result. So I just wanted to show you that really it could be achieved in either way in this case. All right, 38 to 44 even will involve this exercise. They're going to give you a line, and you're supposed to find the equation for that line. And all of your equations will be in the form of y equals mx plus b. So b in this case we can see is 0. That's the y-intercept. And then again, using rise over run, the slope is up 1, right 2. That's 1/2. And so we put those together, and of course we wouldn't say plus 0. And so that would be the equation for line L in this problem. Just a reminder from previous Algebra 2, probably Algebra 1, that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. So, perpendicular, let's just touch on that for just a second. If I have a line that has a slope of 3, for example, the line that's perpendicular to it would have a slope of negative 1/3. If a line has a slope of 3/2, then the perpendicular line would have negative 2/3. And then a slope of negative 1/4 for a particular line, the line that's perpendicular to it would have a slope of positive 4. So just a few examples there. And then the rest of your problems are going to be you being given information about a line, and then you just have to come up with the equation. And again, all of your equations are going to be in slope-intercept form. So let's take a look at 45 here. Find an equation for the line with slope of 3, and it contains the point negative 2, 3. So everything we need for, there's basically two numbers that we need for writing this equation. We need the slope, which we have. What we don't have is the y-intercept, but we can use this ordered pair. These two numbers represent x and y in this equation, and we can plug all these in and solve for b. So y equals m times x, and then we're going to solve for b. We add 6 to both sides. B is equal to 9. So my final answer here is y equals 3x plus 9. Okay. A slope of being undefined is always going to describe a vertical line. Okay, so here's an example. Vertical lines, let's just put some ordered pairs here. Let's say this is the point negative 3, 2. And then this would be negative 3, 1, negative 1. All right, so if you tried to do the slope formula to find the slope, and you subtract the y's, negative 2 minus negative 1, over negative 3 minus negative 3. Well, the top you would get negative 1, but the bottom creates a problem because negative 3 plus 3 is 0, and you can't divide by 0. So that's just an illustration. Anytime you see that the slope of a line is undefined, it's telling you that this is going to be a vertical line. So what we know on this vertical line, it contains the point 2, 4. Well, if 2, 4 is on that line, and it's vertical, that means every x-coordinate on that line has to also be 2. So therefore, this is describing the vertical line x equals 2. Horizontal lines, however, have a slope of 0. And this particular horizontal line contains the point negative 3, 2. So it's completely horizontal going through that point. And as you can see, there's two ways of looking at it. Every y-coordinate on this line is 2. And you can also see that it's going to cross the y-axis at 2. So in slope-intercept form, it would look like this. And simplified form, it would be that. Okay, we have a line that's parallel to y equals 2x, and it contains the point negative 1, 2. Well, the slope of this line is 2, and since the two lines are parallel, I'm going to use the slope of 2 when I write the equation for the line that goes through negative 1, 2. So again, y equals mx, and we're going to solve for b. So I add 2 to both sides. B is 4. So the equation is going to be 2x, y equals 2x plus 4. Okay, we have a line that's perpendicular to this line. This line has a slope of 1/2. So the line that's perpendicular to it will have a slope of negative 2. And so I'll use slope negative 2 and that point to help me come up with the equation for this line. So y equals mx, and then we're going to solve for b. Negative 2 equals negative 2 plus b. So b is 0. And so my equation is just y equals negative 2x. You wouldn't say plus 0. All right. We have another line that is perpendicular to x equals 8. So if you have to draw a little picture, we'll say this is x equals 8 vertical. And we have a line that's perpendicular to it that goes through the point 3, 4. So to be perpendicular to it, of course, it would have to be horizontal. So you can kind of see where we're crossing the y-axis, and so that line would be the line y equals 4. All right, that's it for your notes for section 2-3. Hope this helps. If you have any questions, let me know.